Some of the most incredible technologies ever developed by humanity were designed for space travel. Two of these remarkable innovations are the Voyager spacecrafts, which continue to amaze us even after decades of non-stop discovery. Although both spacecrafts are on their separate missions, Voyager 1 has just detected a massive object hurtling through space. What was unexpectedly found traveling across space near the Voyager spacecrafts? How will this affect Voyager's future space exploration? And why does this newest discovery have scientists scrambling for answers? Let's find out. As part of the Voyager program, NASA launched Voyager 1 on September 5, 1977, intending to study the outer solar system and the interstellar region beyond the Sun's heliosphere. Voyager 1 launched 16 days after its twin, Voyager 2, and became the first artificial object to enter interstellar space. Its purpose aligns with NASA's mission to explore the furthest reaches of space and the deeper levels of our solar system. Voyager 1 has been traveling for more than 45 years and is now the object created by humans that is farthest from the planet, estimated to be 14 billion miles away. Despite this distance, light from the Voyager 1 spacecraft only needs 22 hours, 2 minutes and 54 seconds to reach Earth, so we are still able to collect new data from the spacecraft despite its far reach into the cosmos. Voyager 1 was launched after Voyager 2 because of a quicker path. It left the asteroid belt before its twin on December 15, 1977, and in April 1978, while around 165 million miles, 265 million kilometers, from the planet, it started its Jovian imaging mission. Jupiter's atmosphere appeared more tumultuous in images returned than during the Pioneer flybys from prior years. Voyager 1 began taking pictures on January 30, 1979, and continued doing so every 96 seconds for 100 hours, resulting in a color time-lapse video that showed 10 revolutions of Jupiter. The spacecraft entered the Jovian moon system on February 10, 1979, and in early March, it discovered a narrow ring around Jupiter that had never been seen before. This discovery alone was a major milestone for the NASA crew back on Earth. Then, on March 5, 1979, Voyager 1 made its closest approach to Jupiter at about 174,000 miles, 280,000 kilometers. Subsequently, it passed by several of Jupiter's moons, including Amalthea, Europa, Ganymede, and Callisto, sending back stunning images of their landscapes and revealing entirely new worlds to planetary scientists. One of the most intriguing discoveries was made about the planetary body Io, where photos revealed a strange yellow-orange and brown globe with at least 8 active volcanoes spouting material into space, making it one of the most geologically active bodies in the solar system. The existence of active volcanoes raised the possibility that the oxygen and sulfur in space may be due to sulfur dioxide-rich volcanic plumes from Io. The spacecraft continued to reveal more, including 2 more moons. Voyager 1 made its first course adjustment after its encounter with Jupiter on April 9, 1979, in order to prepare for its rendezvous with Saturn on October 10, 1979. A second adjustment ensured the spacecraft wouldn't collide with Saturn's moon Titan. In November 1979, it made a flyby of the Saturn system, which was just as stunning as the first encounter. 5 new moons were discovered by Voyager 1, along with a ring system with thousands of bands and wedge-shaped transient clouds of minute particles in the B ring, dubbed spokes. A new ring, called the G ring, and shepherding satellites on either side of the F ring maintained the ring's sharp edges. The spacecraft captured images of Titan, Enceladus, Dione, and Rhea during its approach to Saturn. The incoming data suggested that all the moons were mainly water ice. Titan was the target that Voyager 1 passed by on November 12, 1979, at around 2,500 miles, 4,000 kilometers. Images revealed a dense atmosphere entirely obscuring the surface, with nitrogen comprising about 90% of the moon's atmosphere. At the surface, there were 1.6 atmospheres of pressure and a temperature of minus 292 degrees Fahrenheit, minus 180 degrees Celsius. According to atmospheric data, Titan may be the first body in the solar system, other than Earth, where liquid may exist on the surface. Nitrogen, methane, and more complex hydrocarbons were also found, suggesting that primordial chemical processes could be conceivable on Titan. At 11:46 p.m. on November 12, 1980, Voyager 1 made its closest approach to Saturn at around 78,200 to 90,000 miles. After the near collision with Saturn, the spacecraft continued its mission, sending back invaluable data and images that continue to contribute to our understanding of the outer solar system and beyond. Voyager 1 set out on a course to leave the solar system at 35 degrees to the north of the ecliptic plane and roughly in the direction of the Sun's motion with respect to nearby stars. The spacecraft was not pointed towards Uranus and Neptune due to the unique need for the flyby of Titan. The first portrait of the solar system as viewed from outside was created on February 14, 1990, when Voyager 1's cameras were oriented backward and took roughly 60 pictures of the Sun and planets. The photos were captured at a distance of 43.7 billion miles, 6 billion kilometers, from the Sun. The famous pale blue dot image, created by Cornell University professor and Voyager scientific team member Carl Sagan, was made from a mosaic of those pictures. This photo has also been referred to as the Solar System Family Portrait. Despite the absence of Mercury and Mars, only Mars's dark side was visible to the cameras. These two Voyager spacecraft took 67,000 photos before the cameras were switched off to save power and memory for the intergalactic voyage. After the last planetary encounter concluded in 1989, the Voyager 1 and 2 missions were declared part of the Voyager interstellar mission, launched on January 1, 1990. This new mission aims to take NASA's investigation of the solar system beyond the region around the outer planets and even farther to the furthest points of the Sun's sphere of influence. Data collection on the boundary between the heliosphere, an area of space dominated by the Sun's magnetic and solar fields, and the interstellar medium is one of the specific objectives. When Voyager 1 passed Pioneer 10 on February 17, 1998, at a distance of $60.90 from the Sun, it took the title of the most distant human-made object in existence. On December 16, 2004, scientists working on Voyager 1 stated that at 9:40 a.m., Voyager 1 had recorded high magnetic field intensity readings, suggesting that it had hit the termination shock and was now in the heliosheath. On August 25, 2012, the spacecraft finally left the heliosphere, becoming the first spacecraft ever to measure the interstellar environment. According to NASA, Voyager 1 detected significant changes in the environment, including an increase in charged particles and cosmic rays in June 2012, marking its entry into interstellar space at a distance of 121 astronomical units from the Sun. This signaled the inner boundary of the heliosphere. It was exceedingly fortunate that Voyager 1 did not rely on solar energy at this stage, as sunlight took more than 16 hours to reach Voyager 1. Voyager 1 was moving more than 10 miles per second away from the Sun, and at this distance it will take more than 73,000 years to travel at present speeds to Proxima Centauri, the nearest star to the Sun at a distance of 4.2 light-years. However, Voyager 1 is not traveling in the direction of Proxima Centauri. Instead, it is moving in a different direction, making a straight line to the constellation. According to a NASA study, Mission Control noted that Voyager 1 reportedly detected significant collisions with high-energy particles. These particles were once believed to be cosmic rays from supernova explosions far beyond the solar system. Along with this rise in high-energy particles, there was a sharp decline in low-energy particles from the Sun. Researchers at Johns Hopkins University confirmed that these two events were sufficient to confirm that Voyager 1 had completely left the heliosphere and was now in interstellar space. The magnetic characteristics of this location appeared to be different from what had been predicted. However, scientists soon saw something unexpected in the data. Dr. Ed Stone, the project scientist for the Voyager spacecraft at the California Institute of Technology, stated, "Voyager has discovered a new region of the heliosphere which we had not realized was there. Apparently we're still inside, but the magnetic field is now connected to the outside, so it's like a highway letting particles in and out. This unusual magnetic field phenomenon revealed that the area was 10 times stronger than experts had first thought it would be, anticipated to be the final obstacle before Voyager 1 left the solar system and entered interstellar space." Since Voyager 1 entered interstellar space in 2012, scientists have eagerly awaited feedback from the spacecraft, as no spacecraft has ever before left the heliosphere in the history of human space exploration. However, they were taken aback when, during one observation cycle, Voyager 1 started sending back strange and, to be frank, terrifying data. The data from Voyager 1 seemed to be generated at random, reflecting very improbable events that weren't expected to occur in interstellar space. According to NASA's Jet Propulsion Laboratory representatives, Voyager 1's altitude articulation and control system was the source of the unexplained data. This system was responsible for sensing and computing Voyager 1's antenna orientation to maintain the probe's alignment with Earth for appropriate signal transmission. Scientists were baffled by the origin of the strange signals and the useless data that Voyager 1 had returned. The probe seemed to function generally since it could still observe, collect data, and relay it back to mission control on Earth, even though the data was essentially useless. Voyager 1 and 2 were nearly 45 years old at this stage in the journey, a lifespan far longer than anticipated at the beginning of the mission. However, despite having several systems turned off to save power, Voyager 1 and 2 consistently sent back accurate and readable data throughout their missions. Since Voyager 1 is currently 14.5 billion miles from Earth, there is a significant lag in the signal exchange between the probe and NASA mission controllers. Over 22 hours pass between the time it takes for signals from Voyager 1 to reach Earth and the time it takes for signals to be sent back to the probe. Mission Control concluded its weeks-long effort to piece together the puzzle of the unusual signals Voyager 1 transmitted back. NASA recently identified the underlying problem. They found that Voyager 1's antenna control system, which maintains the probe's antenna pointing constantly toward Earth, had experienced a glitch. The system started transmitting data via a damaged computer that had been turned off years ago. Although the data was correct and readable on its own, it became corrupted during transmission through the damaged computer, sending useless telemetry data back to Earth. NASA claims that after identifying the source of the issue, they merely needed to issue a new instruction to Voyager 1, telling it to cease transmitting data to the damaged computer and start utilizing its healthy computer instead. According to NASA, this was a simple adjustment, and Voyager 1 is now delivering accurate data regarding its most recent views of interstellar space. Despite not receiving a directive, scientists are still trying to determine why Voyager 1 started utilizing the faulty computer. There have been several speculative theories in the scientific community. The changeover to the corrupted computer was most likely brought on by Voyager 1 coming into contact with some kind of cosmic radiation carrying charged particles that warp system instructions. While mission controllers believe this was an isolated incident, there has been widespread speculation that the likelihood of a similar situation occurring again is highly likely due to the unknown nature of interstellar space. However, this remains a theory, as NASA has not yet provided an account of what they believe was the cause of the system malfunction. While Voyager 1 has been in interstellar space for much longer, Voyager 2 only recently entered the region of space in 2018, and it may soon encounter the same issue that Voyager 1 has faced. Voyager 1 has been essential in advancing our knowledge of the solar system's planets and the heliosphere, which was previously just an abstract idea. Both Voyager 1 and 2 are now 45 years old, yet they were initially intended to last just 5 years. Mission commanders are optimistic that they can prolong both probes' useful lives until 2025, until their power sources run out. In the following 3 years, Voyager 1 will continue to be able to send back data. However, that won't signify the end of Voyager 1's galactic journey. In about 300 years, the space probe is predicted to maintain its current speed and enter the Oort cloud. Mission Control included the golden record in Voyager 1's construction in anticipation that the probe would drift across space for hundreds of thousands of years. This record contains several messages, including greetings in 55 languages, recordings of various performers, and a child's voice, in the improbable event that Voyager 1 discovers extraterrestrial life, allowing them to receive a taste of what life is like on Earth. Voyager 1 will stay within the solar system until it leaves the Oort cloud in another 14,000 to 28,000 years. However, if we define our solar system as the Sun along with everything that principally orbits it, the communication capabilities aboard the probe will ultimately become unattached from Earth, continuing to drift across space for all eternity. The satellite is anticipated to maintain a connection with Earth until 2036. The Voyager 1 satellite probe travels at an approximate average speed of 39,000 miles per hour, using the orbit of each planet to propel it to the next. Thus, it is the quickest spacecraft that humanity has ever created. There are still many discoveries that this spacecraft will make, some of which may happen even in the lives of the next generation. However, this will only last until NASA completely loses communication with the spacecraft. Voyager 1's ongoing journey offers a unique window into the mysteries of the cosmos, revealing not just scientific phenomena, but also stirring the imagination of humanity. As it travels further from our planet, it serves as a testament to human ingenuity and curiosity, continuously providing data that can reshape our understanding of the universe. The spacecraft is equipped with various instruments, including cosmic ray detectors, magnetometers, and plasma science tools. These instruments allow scientists to study the environment of interstellar space, where conditions differ significantly from those within the heliosphere. For example, Voyager 1 has detected higher levels of cosmic rays, which can help researchers understand the source and behavior of these energetic particles that permeate the galaxy. In addition, the data collected by Voyager may first aid in the quest to understand dark matter and dark energy, fundamental components of the universe that remain largely elusive. As the probe ventures farther, it could also provide insights into the heliopause, the boundary where solar wind particles collide with interstellar medium, offering clues about the interaction between solar and cosmic environments. Moreover, the longevity of Voyager 1 demonstrates the resilience of space technology, showcasing the ability to operate beyond its initial lifespan. This resilience inspires future missions, encouraging innovative designs that push the boundaries of exploration.